Okay, this is lesson 40. It's actually a recap on the previous one and then we're continuing on it. Because we're busy with trig, and trig is a very broad spectrum of things. We are only at the tip of the iceberg at the moment. Trig gets very complicated and there's lots of information to come. So please stay with me. Keep up with the pace, and it's going to be quick. Alright, the first question that you're going to get, except for the trig graphs that we finished, the first question usually is the question on the Pythagoras sums, where you are on a Cartesian plane and you choose one of the Pythagoras, one of the butterflies, and you're going to work out two sides given, work out the third side. So usually we have to have all of this information, knowing that sin, cos and tan, and this is Afrikaans. And how you remember it, nobody cares, as long as you know. And I teach my kids orange, apple, Who cares where that comes from? Some people like tua, right? Some old hens, whatever. What are you with me? I don't care. As long as you know that sin is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. That's the essence of it. How you remember it, no one cares. Then I showed you how it works, why these different graphs of positive and negative in the different quadrants. If you actually look at a graph, you'll see that, for instance, cos, I'm just going to look at one of them quickly. That's quadrant 1. Because the quadrants works from 0 to 90 to 180 to 270 back to 360. And the same thing over there. So we've got 0 to 90 degrees is the first quadrant. Now I can either express my graphs like this, carrying on until infinity with a cos repetition on the left hand side as well. But basically for the first 4 quadrants, there's quadrant 1 up to 90 degrees. Quadrant 2 goes from 90 to 180. Do you agree with me? And then there's 270, and there's your fourth graph up to 360. Now about the cost being true, I'm just checking for cost quickly just to remind you. In the first quadrant, remember what is sin, cos and tan? They are the ratios of two specific sides in terms of an angle. So whatever the angle may be, the sin and the cos and the tan of that angle is the sides in ratio to each other. So in other words, if I want to go work out sin, oh no, sorry, I'm busy with cos. Cos 50 degrees, for instance, it'll be that answer over there. Your calculator gives it to you. But it'll be a positive answer, 0.4, 0.5, I don't know what it is. And cos 60 will be something positive, but cos 100 will be something negative. Cos 170 will be something negative. Cos 200 will be something negative. Cos 300 will be positive again, etc. So that means cos is positive in the first quadrant and in the fourth quadrant, where in the second and third it's negative. So that's why it comes to cos being positive in the first and the fourth. And the same with the rest, they fell in here, meaning that sin is positive in the first and the second, tan is positive in the first and the third, cos is positive in the first and the fourth quadrant, because that means all of them. Right. So now I also have this butterfly thingy that we're looking at, which we are going to use in our first question. Usually it's the first question in the question paper. Look at your exam aid as well. If I say, if sin of theta, a specific angle, is equal to 3 over 5, which is 0.6 if you want to go take it into ratios, and I tell you that tan is negative, then I'm saying, find cos. But very important, I have to say without a calculator, because it's possible to find it without a calculator, with a calculator. If I wanted to find theta, could I do that here? Yes. How? On your calculator. How? Shift sin. Then I take ratio back to angle and I'll get the exact angle. Say for instance, I don't know what it is. Say for instance it's 50 degrees. The answer for theta is 50 degrees. Then can I get cos theta? Then it's cos 50 and I got the answer. No marks, because I say no calculator. And then usually I say, and a hint is use a graph, use a sketch. But even usually kids that don't know to go get me the sin graph. They want to actually go sketch the sin graph. That's not what it's about. If I say with the use of a sketch, I'm telling you go and do the butterfly sum. So you need to identify the specific sum, because I'm not going to say, hey, this is the Pythagoras cast sum. Please remember to draw the sketch and make it in the correct quadrant. You've got to know when you read the sum, aha, that's the Pythagoras cast sum. So I know that sin is positive or negative? Positive, and tan is? Negative. Less than 0 means negative. So then those two facts, I've got to give you enough information. If I just said sin is positive, where am I working? Two possibilities. And I can't do that. You've got to know where to work. So that's why I said, but tan is also negative. That means I'm going to be working in the second quadrant. Because sin is positive, but tan is negative. So I'm using the cast information to find out that I must go there with my butterfly. And not that way. The butterfly must be one of those 4 options. And your angle, and the name of this angle is? Theta, sits over there. Then I've got to, it's Pythagoras as well, I've got to go get my sides and I've got to put them on the graph, and I've got to have 2 and be able to work out the third one with Pythagoras then. So what does the 3 and the 5 represent for the sin ratio? The opposite and the hypotenuse. You see millions of little things working together here. So then 3 and 5 is opposite and hypotenuse. You are where? That's where your little angle is. That's where you always will be in the 4 choices. So if this is the angle, then the 3 is opposite and the hypotenuse is there. So you are searching for x. Alright, because we always talk about x here, and then this will be y, and this we always call the radius. Like we're working with a center of a circle there and putting the radius through it. So the radius. So then what will this x be, guys? 4. Negative. Excellent. Negative 4. Excellent for seeing that it is the golden triangle. It's very specific. So knowing that it's 4 but you're not quite right, it must be negative 4, because look at the quadrants where you are. Make a note for yourself. Whenever you are in any one of those quadrants, what's going to happen with the values of x and y? In the first quadrant, that x is plus and that y is plus. Agree? Yes. In the second quadrant, the x is negative but the y is positive. In the third quadrant, the y is negative and the x is negative. In the fourth, the x is positive but the y is negative. So what about r?
Positive.
Why does r have to be positive? Because r represents a radius. You can't have less than nothing of a radius. So the radius will always be positive. So when you're working out stuff, it has to apply to the practical. So in this, the practical was you were on the left-hand side of the x-axis, meaning it must be negative. So we found out that cos then is equal to adjacent over hypotenuse. Negative 4 over 5. And that was the end of that. Another example which you did was that tan was 4 over 3, which means it's positive. First of all, when you see the sum, it's going to be together with lots of trig, and you've got to realize, aha, this is the Pythagoras cast sum. So I give you tan, and I give you something else, and then I'm asking you for something, and then very important, I say no calculator, because otherwise you could have worked out the angle and put it in there and boom, you finished. No calculator, and with the aid of a sketch or a graph. I don't like the word graph because then the kids want to draw the graph of tan. And that's not going to help you. Alright, so if I have to do that and you realize, oh, okay, it must be that Pythagoras cast thing. Where's the butterfly going to be?
Third quadrant.
So tan is positive where cos is negative. And that can only be in the third quadrant. So you're going to get a mark for knowing that it's third quadrant. Then you're also going to get a mark, well not a mark, but you've got to specify where are you at. So one of those angles, so you are here, and the angle's name is again? Theta or whatever. If I wrote A, then the answer, the name of the angle is A. The two sides that are represented are opposite and adjacent. So opposite from me and adjacent from me, is that correct?
Yes.
It will be negative 3.
Negative, because look at where you are. But man, it's not negative, it's positive, yes. But if they are both negative like they should be, according to the practical of it, both negative, negative, negative does give me a with me.
Yes.
And again, do you see the golden triangle?
Yes.
So that my R will be equal to
5.
and you've got it with Pythagoras. Even if you do it on the sketch, but you've got to say Pythagoras, alright? Like I did there as well. If you want to write in there y equals and x equals, it's fine. Now to get to the question was, what is sin squared plus 1? So all you need to know after that, I can only ask you something that refers back to the sketch. Whatever I ask you, I can't ask you, go get me this. Because where's that angle? It has to be the angle that's in the sketch. Go to the sin ratio, and what have you got to do with it? Square the ratio and add 1, and plus, and root, and whatever the teacher wants to put in there. But this means something very important that you need to know, should have known already, is if we say sin square, it means the sin ratio, which is negative 4 over 5, do you agree?
Yes.
But squared. Is that correct? You were taught that if ever I want to say sin, let's square that. Then you should either say brackets with a square, which is too much of a drama. We'd rather just say sin, but can you do that?
No.
No, because then that means just the angle is squared. To then prevent that, we've made the rule of writing it over there, but it still means it's sin squared. And then plus 1, root something, whatever, I don't care, calculator. But man, they said no calculator. That's not why they said no calculator. It was to go to the sketch, not go and work out the angles, etc. When you hear, I'm very happy if you just give me the answer. So if you just type it into your calculator, or you can go and do it on your own, but you're wasting time, and give me the answer. I think it was 41 over 25. Can you leave it like that? Absolutely. If your calculator leaves it like that, you do that as well. Unless I asked you to give me the answer 2 decimals, then you do what I asked you. But you can leave it like that. Remember, we're busy with sin, cos, tan ratios. So this is a ratio. Leave it like that. No problem. All right. Alright, the other way of asking this Pythagoras and cos question, because usually we don't ask it in one question paper, especially when I give you an SPA of 50 marks or 100 marks, which never happens because we don't have time, and I say it's all the trig, then I can start asking every single variation. But in a test, we usually ask one of the two. So it's either the one I've just shown you or this right in terms of. Now this is my own personal abbreviation. Find in terms of, it's just too long to write it out, okay? It's not an abbreviation in English, I've just made it up myself. So if ever they ask you to write something in terms of, you must know this. I'm teaching you to identify the specific questions. So if I say, I'm giving you something like, if sin 20 is equal to k, then find in terms of k. That find in terms of, I want you to grind into your memory, start making the connection that you're going to be wanting to work with this Pythagoras cos thing. So if I say that, you need a butterfly, right? Yes. But I'm only giving you one piece of information. Should I give you more? I'm giving you that the angle is 3L. There's no question about it. Because 20 degrees, and you're not measuring it, but it's going to be in the first quadrant. Okay? Then there is going to be later on that you're going to have 100 and something, but that's the reduction formulas to come. Now guys, like I said, you're at the tip of the iceberg. We're going to be doing a lot of things. And in 3 days and 5 days time, I can come back to something and now you've got the knowledge to do something else. For now, I can't do that. I'll only stick to before reductions. Alright? So if I say that sin is 20, where's the 2 signs I'm going to be putting on here? Oh, fantastic. It's k and 1. And that's usually how the sum goes. But nothing prevents me of saying, well, I want it 1 over k. Then it's 1 over k. Or 6 over k. Whatever. But if it's only k, it's over a 1. Usually that's what they ask. But then what does sin represent? Which two sides are these? Okay, so opposite is k and hypotenuse is 1. And then you're always going to go back. Remember, it's Pythagoras cast and the butterfly. So there's the butterfly. I'm not really using cast because nobody has to know where is 20 degrees. You know it's supposed to be the one. And then to go and work then with the two sides on Pythagoras, you're going to have to work out what this side here is. Now, how will I do that? How will you get that x? With Pythagoras. Okay, now it's not numbers like 3, 4, and 5, which they love, but you're going to actually just do the Pythagoras. If you want a side that's not the hypotenuse, if it's hypotenuse, it's the sum of the two other ones. If it's not, then it's the difference of hypotenuse squared minus the other one squared. That's Pythagoras. Pythagoras only exists with squares. The square on the hypotenuse is the sum of the squares on the other two sides, nothing else. So the squares. And the reason for that is Pythagoras. And now I can get the x by doing what? Square rooting. No. Can I factorize this? Yes, you can. Why would you?
Difference of
You're able to, but you don't have to. Why? What are you going to do with it? Sometimes things that you can do is not necessary to do. Alright, so this answer, and 1 square, by the way, is just 1. That's my answer. Can I not get it out of the root? Why not? Because there's a minus. You can only get stuff out of the roots if it's all multiplication. Then you can get it out of the root. So that's the answer, guys. So over here, I know that the answer is 1 minus k squared. That is the answer. Now, if I want you to go write cos 20 from the graph, I can't ask you now for cos 21. It has to be the angle that's represented on the sketch. I can ask no question here that's got nothing to do with 20 or some other way that's still to come. So if I want something on the graph, it has to be the 20. I can't ask 21, 33, whatever the case may be. So for cos 20, read off cos 20 would be? Yes, that 1 minus k squared over 1. Is it necessary to write over 1? No, but if you do it, it's fine. But you cannot simplify that because of the minus. Okay, and now I can ask you 1 question, 6 questions, depending on how many marks I want to allocate here. What would then be sin squared of 20 plus 1 or whatever it feels like? So you're going to have to go and look at sin and square it, and then add 1. So now if I do go and say sin 20, it will be k over 1. Actually a stupid question because there it was. Sin 20 is? Are you with me? Whether I read it off or whether I just find it there, it's fine. So the answer is k squared plus 1. Boom. Nothing, simplification, there's nothing good that you're able to do further than that. Tan 20, are you seeing what I'm trying to show you? 20, 20, 20. I can ask nothing other than 20. Well, I can, because how much is this?
70.
So if I ask you something about 70, would you be able to? But then if you hear, this is adjacent, and this is opposite, so I can. Are you with me? But it's got to have something to do with this sketch. 20 degrees, and by implication 70 then as well. Alright, and so tan 20 then would be opposite over adjacent, which is k over that root thing. Do you not like the root at the bottom? You shouldn't. What's the story about a root at the bottom? Rationalize the denominator. If you ever get an answer like this, do you read about that? No? The calculator does it anyway for you and shows you that it's root 2 over 2. But if there's a variable, can you say for certain that this is an irrational answer? So please just leave it. I'm teaching you something here. But that was in exponents, and now we're here in trig. Lots of stuff do correlate with each other. So I'm at a question where I've got a root in the bottom. Normally we don't want that, but if there's variables in, leave it. Don't start rationalizing this, it's going to be chaos. Here you would, because it's normal. numbers. Are you with me? Now guys, the only thing that can happen with these sums, and after a while and very quickly because we don't have time, you're going to find out that either it's always going to be the first quadrant, so you could maybe have the k was there, maybe the k was here and the 1 was there. How would you find that? Or maybe the k was here and the 1 was here. How would you find? Are you with me what I'm getting at? That's all that can happen. And if I don't like k and I'd like to ask you something with p or with t or with whatever alphabet letter, it's going to stay exactly the same thing. So when I ask you in terms of, you know you're going to get the sketch. Once you've got the sketch, you've got to go get the Pythagoras. So what will this answer be according to Pythagoras?
Square root of t squared minus 1.
Square root is of p squared minus 1. The hypotenuse minus that 1. When it's not the hypotenuse, it's a minus sum. When it is the when it is the hypotenuse you're looking for, then you're going to have a addition sum. T squared plus 1 squared, but in a square. And that's actually all that can happen. So what I'm saying is you're not always going to show me all of this. If you immediately know it and write it, then you write Pythagoras, I'm perfectly happy with you. Because it's all that can happen. Whether it's in terms of K or P or what alphabet letter, doesn't matter. You're going to have two of the values, which normally is the K or the P and 1, and the other one. Can you see that it's going to always look the same?
Yes.
You just got to follow whatever I ask you and read it off and simplify. So for homework, to go and practice this, and this is it guys. Pythagoras passed in the butterfly, then tomorrow we're starting to do the reduction formulas. So the first question, let me help you because it's a little bit different than what we've done today. First question says, if 2 cos theta is negative 1, and tan is? Positive. Are you seeing two pieces of information? So are you finding the little pattern in my words that you're thinking, oh, Pythagoras cast? Are you with me? Because otherwise you're going to sit there and not know what to do, and when you come into class and you see the mirror, you say, oh, it's the Pythagoras cast. But you didn't see it because you didn't know how to recognize it. So, but what's different on this thing? Then number 2, wow. Just take it away. It is multiplied, so
Divide.
divide. Then you've got cos, so that I can see. Cos is minus 1 over 2. So the minus 1 and the 2 are the two values that I'm going to look for, that I'm going to put on the graph. Same story as always. And this one, if tan 33 or whatever man felt like was equal to k or p or t or whatever, find in terms of k. Please remember that's not an English abbreviation, it's just Mrs. van Skalkwijk's abbreviation. Find then 2 cos squared 34. No, you can't ask that. It's got to be something that you've got down in your sketch. So everything I ask here has got to be something to do with 30. Are you happy? Okay.